Can I introduce, first of all, our first speaker, Rob Lewis. Rob is Managing Director of Total Sim. So, Rob, how do you see the corridor? Rob, here we are.
Thank you. Okay, I work for a small company in Brackley, about 5 miles that way. We're engineering consultants. There's 30 of us. We've been doing it for 10 years. And I'm going to show you a couple of projects we've been doing in the area and talk a little bit about the corridor. So this is the sort of thing we do. We help design and develop motorbikes, cars, caravans, things that flow. So asthma inhalers, heart valves, but mostly vehicles, and quite a lot of work in high-performance sport. We use lots of compute power, lots of mathematicians, computer scientists. It's all fairly geeky, but we originated in motorsport. And I've drawn a little map here with a cloud in the middle, and this is my sort of motorsport map. And where it started was, I think, Cosworth, Mr. Duckworth and Silverstone started a cluster of motorsport companies from March in Bicester, that Adrian Reynard started Reynard Motorsport, British American Racing, and we came out of Honda F1 and Reynard Motorsport. And so we're just one little leaf in a whole tree of motorsport spin-outs in the area, and there are literally hundreds of them. But it all goes back, in my simple view, to Cosworth, Silverstone, and as pioneers in the late 60s. So we've got a cluster of motorsport companies in the area that have been slowly diversifying into other things. So one of the areas we've done a lot of work in is high-performance sport. We worked on Olympic bikes for the last 3 cycles, helmet suits, positions, handlebars, you name it. So I did a lot of work there, won quite a few medals. And we looked at that and said, what this sport needs is their own tunnel. So what would happen is Chris Hoy goes to the wind tunnel and says, oh, that's low drag. Then he gets to the track and the arms come out as he tries to produce power, and he makes horrible drag and nice power. So we designed a wind tunnel as part of their training environment that looks like this, and the idea was that would sit as a piece of gym equipment and they could use that as part of the training cycle. So we formed a new company with another company in Brackley and Chris Boardman called Sports Aero Solutions. Designed a tunnel using our computer methods that we learned from F1 and from motorsport. And we came up with a bike-specific tunnel, some techie details there, but the key is this is a product that's unique for bikes. It's low cost, easy to run, and it means that your keen middle-aged men in Lycra can get into the wind tunnel and do some tests for 100 quid, 150 quid. We sold the first one, not surprisingly, to Boardman Bikes, to Halfords in Evesham. This place is now open for business, and they have a wind tunnel that we designed in Brackley and engineered in Evesham, and you can go and rent time in there from next month. So there's some more pictures. That's being final commissioning at the moment. So this was built using local companies and local technology to the area in the Arc and applied there. But this tunnel will then be sold around the world. This is a product. So developed in Motorsport Valley in this Oxford to Cambridge Arc, and we should be selling them all over the world next year. So next, from there, we said, well, there's a nice wind tunnel at Halfords, but really we want a techie wind tunnel where you can do secret things. And through a collaboration with BT VLEP and MEPC, we purchased a unit across the road, 26,000 square feet, and we're going to develop the Silverstone Sports Engineering Hub. So at the moment, the fit-out's underway. We're going to put a similar wind tunnel in there, and we're going to create a place where businesses can innovate, collaborate around sports engineering for cycling, triathlon, and so on. So from January, there'll be 2 wind tunnels in there, and I'm hoping in about a year's time, there'll also be a swimming flume, and we can do some unique testing around swimming. So that's an early glimpse of the flume and the mechanical efficiency rig. So again, it's the high-tech in this area, diversifying into other things to create new opportunities and business. The swimming flume would be a world first. So how did this happen? This happened through collaboration within the Silverstone Technology Cluster with support from MEPC, encouragement from MEPC, funding from BT VLEP through the Local Growth Fund, funding from SEMLEP through the Ready to Grow Fund and the Northamptonshire Growth Hub, and also because it's based in the enterprise zone, we get an extra boost in rates. So all of this kind of adds up to, I'm a small company, stood on the 10-metre board looking at this project of 5 million quid, and it's scary. And all of these gave me that little nudge and support to take the leap and do something that I wouldn't otherwise do. And then we've got local companies like Hawkins and KWSP to make it happen. But why did it happen? And this is quite important. The reason it happened is in 2003, UK Sport went shopping for high-tech and for advantages to get medals, and they went shopping here in motorsport land near Silverstone and around Silverstone, and they came to BAR Honda and they said, how can we make our bicycles quicker? And that's quite important. They came to the cluster. So we need to expand the cluster. Other project, this one I've been working on for a little bit longer, Catesby Tunnel. So the idea here is we design things in aerodynamics and we want to test them. In Germany, they have a series of 80 million euro, 80 million pound wind tunnels, and we don't have any in the UK. So we thought we'll do it with a 1.7 mile disused tunnel near Daventry. So we set about purchasing the land, the lease option, the planning permission, the funding to turn this into a test track. So in some ways this is better than a wind tunnel because the real car's on a real road in controlled conditions and you can measure all sorts of things and do controlled tests. So the location is just in the right place, 20 miles from our offices, 15 miles from JLR and from Aston Martin. And we formed a partnership. We've gone through the process of planning permission. We've got planning permission for the building, for converting the tunnel. We've also got planning permission for a science park at the south end, where we're hoping to create a cluster around vehicle testing, instrumentation. This will mostly be for automotive, a lot of work around emissions, a lot of work around noise. As electric cars come out and evolve, they get quieter. As they get quieter, then aeroacoustics becomes important. So the project at the moment, we're constructing the building. We've spent around £4 million of local growth money that we worked with SEMLEP and NEP to achieve. And that really has unlocked this project. Without local growth funds and the support of SEMLEP and Daventry District Council, this project wouldn't happen. And now we're about to go into the tunnel and convert the tunnel, spend another £8 million, and we're on the edge of attracting £14 million from Japan, from an automotive OEM over there to invest in this project. But that wouldn't have happened without Local Growth Fund, SEMLEP and Daventry District Council, again pushing the project off of the diving board. So there's a view, as it was last week, from the tunnel with the test building in place, or the structure of. So again, SEMLEP, Highways England have supported us, provide the tunnel, provide the support for getting the project going. But also it's the local engineering companies that are helping us make this happen, from heat exchangers to architects, instrumentation in the road, lasers, acoustics. Again, it's all within the local area and the cluster. But also this test facility is totally in the right place. So we were very lucky to find that the only available and useful tunnel for this was slap bang in the middle of Motorsport Valley and automotive. So you can see on that map there, we're literally next door to most of our customers. So there's two examples. So what's working as a small business in this area, in this arc? Funding is good. We're getting funding from Local Growth Fund, from BTVLEP and from SEMLEP, also from the Growth Hub and University of Northampton. That's great. Networking from SEMLEP, BTVLEP, and also Silverstone Technology Cluster. That's really good. That's working. Events from University of Northampton, Cranfield, and so on. And the support from all of the above is good. The location is really good because we've got lots of like-minded companies. We don't do a lot with Cambridge, strangely. I think there's technologies there we could reach out and grab. But another key part is history and contacts. All of the people over the last 20 years that we work with in motorsport are out doing different businesses now, from biomedical to healthcare and green technology, and we're working with them, applying our tools. What's needed, this is a simple engineer's view of what's needed, is, as I said, simplification. Running a small business of 30 people, turning over 2 or 3 million quid, is tricky enough, but all of the schemes, R&D tax, EIS, they're great, but it's very complicated. Simplifying the system would be good for me. And more clarity about what's out there, what the opportunities are. The growth hubs give small businesses good clarity and access to those things, but I think it could be clearer, and I think it would help if some of the departments didn't change their name quite so often. The other one is keep investing in innovation. It only takes a little nudge for me to, or a company like me, to do a project that we wouldn't otherwise do. So the Catesby facility, that will attract investment from all over Europe to use the facility, and while they're here, we hope to sell them services and products. But it only takes a small nudge or a small investment to start a snowball effect. We need better networking and collaboration across the corridor. We've got our own little pocket here around Silverstone, but we need to connect that to Oxford. We need to connect that to Cambridge, not just road and rail, but getting the engineers and scientists talking to each other. And we need funding for this. You know, not just for the cups of tea and the sandwiches, but to fund small kick-off projects that get us collaborating with a biomed company in Cambridge. But also, my last whinge is we need more investment in employer-driven education. We need to set the courses, choose the students, and have more control over the education system, because, quite frankly, at the moment, it's not delivering what we need as high-tech employers. That's me.
Thank you.
Okay, thank you very much. I'm delighted to be here. But before I give you my vision of what I think of the corridor, I'll just say what Oxford Biomedica is and what it's done. So the company is 21 years old, spin out from the biochemistry department in Oxford. I joined it in 1996. There's 5 of us in one office. Since then, we've developed the gene and cell therapy technology that came out of the university into a number of different applications, treating cancer, Parkinson's disease, genetic causes of blindness, hemophilia, potentially also cystic fibrosis. So it's a multidisciplinary application, and also a completely disruptive technology, in that it's going to create a new arm of pharmaceuticals, and it's different and disruptive because it's a type of treatment where ideally and hopefully you only treat the patient once. And if you can think about what has happened in the past to pharmaceuticals, most drugs have been designed to treat symptoms, and you keep taking the pill the rest of your life. With gene and cell therapy, this is a treatment where the patient only gets treated once. Now, you may have seen in the middle of last week there was an announcement that the National Health Service had signed a deal with Novartis to commercialize a new treatment for leukemia in young children. And this is one example of cell therapy. And at the heart of that particular product that's called Kymriah is technology that was developed in Oxford by Oxford Biomedica. So this particular product that's been now commercialized, now going to be on the market in the UK, has, if you like, the Intel inside, or like the ARM technologies in a biotech sense, is going to be Oxford Biomedica's gene delivery technology. So what does that mean in practice for the company? So when I started, as I said, 21 years ago, 5 of us in one office. Today we are approaching 400 people, probably be 500 by the end of next year. There's been very rapid growth in the last 3 years. Now that's created some opportunities. It's also had some challenges, particularly as we were based on the Science Park in Oxford. We moved out to get more space, and to manufacture these particular products is very high tech. It requires a lot of key skills and needs a lot of space. But they are high value products. So, and that's driven part of the need for more people. So, in general sense, the barriers to growth, we haven't had any problems recruiting the key skills, apart from 1 or 2 specialized areas. But I think, as you heard from the Minister, one of the problems we have is that even if you bring in a highly qualified postdoc scientist, these days aspiring to live in Headington is impossible, unless they've got private wealth. But 20 years ago, that would have been entirely feasible. So a lot of the people we're recruiting, who are highly educated, highly qualified, are commuting big distances. because they want to work in Oxford. At the same time, access to the space to develop the business, have the manufacturing capability, which in its current state is most advantageously positioned if it's close to the R&D hub of the center of the company. As we scale up the business, then it probably won't be so important to have it so close. But trying to find the right sort of space into which the right sort of people will want to work hasn't been easy, but we have succeeded so far. So the biotech cluster around Oxford, we're 20 years old. So if you look at the iceberg, there are others like Oxford Biomedica, like Immunocore and Adaptimmune, Cioxis, and they're all going to be and are experiencing the same barriers to growth. But beneath them, under the surface of the iceberg, we know that the university is now spinning out more companies per week than they have ever done over the last 20 years. So the question you have to ask is, where are these companies going to go as they grow and expand? And some of them will want to become the Immunocores, Adaptimmunes, and the Oxford Biomedicas of the future. That they will need to access the right space and get access to people. So one of the advantages I see of the arc, or the corridor, is that it will connect all the clusters that exist all the way along the corridor. And to some extent, these are all in different disciplines. So we can go all the way, well, I'm in the middle of Oxford, so I look to the south, I see Harwell, has huge skills, a big cluster around space, satellite technology, houses the Rosalind Franklin Institute, specializing in interdisciplinary research. And as you come back through to here with motorsports and beyond. So we can all see in our own little clusters, but I think if you want to imagine trying to encourage where some of the serendipity might occur in looking at interdisciplinary applications of what we do, it's important to have these areas, these clusters, connected in a better way. At the moment, it's far too difficult. To even go from the center of Oxford to Harwell can sometimes take more hours than it should if the A34 is closed, for example. As far as Oxford Biomedica is concerned, its lead clinical program in Parkinson's disease, one of the clinical centers, is in Cambridge, at Addenbrooke's. So traveling from Oxford to Cambridge, as everybody knows, can be a real challenge. And if you're having to go there on a regular basis, it just makes sense. You just want to join these links up. So I think as far as the corridor is concerned, interconnectivity, multidisciplinarity, and as that all comes together, you will create a much bigger critical mass. And for me, having had the company having to invest in manufacturing space, so having capital investment programs to build manufacturing space. In the future, other companies that come after us, I think, there will be specialized development companies that will come in and build that for you, and then the high-tech companies will merely be able to move in and rent the space. This is what already happens if you go to Cambridge, the fake Cambridge in Massachusetts, and other places like San Diego or the Bay Area. So that is my vision for the corridor in a biomedical sense.
Peter, thank you very much indeed. From the programme, we now have Keith Mason, who is the Principal Development Officer at Satellite Applications Catapults. Keith, keep it tight.
Thank you. Good afternoon. Yes, so I'm from the Satellite Applications Catapult. I want to give you a perspective of how we see the ARC and the potential for developing the space sector, which is our principal mission in life. And I wanted to focus, as an example, on the work that we're doing in Westcott, which, if I press the right button, is right in the middle of the ARC. And Westcott, like Silverstone, used to be a World War II airfield. And then it became the UK's rocket testing site, and this is a Blue Streak rocket engine being tested at Westcott in the 60s, 70s, sometime like that. But now it's in private hands, and it's a center of high-tech engineering for rocket propulsion. And this picture is actually a picture of the NASA Juno spacecraft, which is currently in orbit around Jupiter. And the engine that got it into orbit around Jupiter was built at Westcott. And the engineering challenge here is that this spacecraft spent something like 5 years in the cold of space traveling to Jupiter. And this engine had to work precisely on time with precisely the right power, precisely the right duration. Otherwise, a billion-dollar mission would have gone up in, well, it would have failed. So that's the sort of engineering challenge that currently goes on at that site. And what we want to do is to take those, what are currently niche skills, and really expand the potential of that and bring it to a much wider marketplace, a much wider set of economic activities. So that's what Westcott currently looks like. It's comparatively underdeveloped, given its heritage as a rocket testing site, which required that you kept people away while you were doing those tests. And as I said, if you don't know where Westcott is, there it is, right in the center of that picture, almost midway along the arc. There's Oxford to the bottom left, Milton Keynes, and Cambridge is lurking off to the right there. So it represents the sort of capability that we should be developing when considering how to exploit this idea of the corridor or the arc, or whatever you want to call it. And we have been interested in Westcott because of its test and verification capabilities initially, but increasingly we're looking at it as a production engineering site as well. And of course, we at the Catapult, we're based at Harwell, and there's a lot of R&D goes on at Harwell, but Harwell is not a suitable place for testing rockets or anything else that might be slightly dangerous. That sort of activity needs to happen though, and Westcott is a perfect place to develop such capabilities. And so we've been developing what we're calling a space cluster at Westcott with the support of the LEP, with also money from the European Regional Development Fund, and we have a number of projects, parallel projects going on, just to illustrate the sort of work we're doing. We're interested in anything that's satellite enabled, and one of the things that certainly will be satellite enabled is 5G communications. Currently we have 4G on our phones, and some unlucky people only have 3G, but within the next few years we'll have the next generation. And the key thing about 5G is that it will incorporate transparently satellite-based networks. So that means that wherever you are on the surface of the Earth, you ought to get a 5G signal. So there'll be no more not spots, and that's very convenient, of course, but it also lends itself to novel applications such as control of autonomous vehicles, or autonomous flying vehicles, UAVs or drones in particular. Because clearly, to have a safe system where you operate your drone at long distances, you need a reliable connection. You can't have it falling down. So that's what 5G will hopefully give you. So one of the activities that we're developing at Westcott is a 5G test center that will allow people to, companies, individuals, entrepreneurs, to develop capabilities and actually test them out in real-world simulation, real-world conditions, so that when 5G networks come along, they're ready to roll out and take advantage, be the first to market. Another project, we're also incubating businesses, and again, the themes of 5G communications, rocket propulsion, and also drones and autonomous systems we're working with companies, startup companies, to develop a community, to expand the community at Westcott, and to provide an ecosystem of skills and capabilities that can be exploited and grown to produce real economic impact. And Peter mentioned the word multidisciplinary in his talk just now, and I'd like to emphasize the absolute, I think that's the way forward. It's vital to think in a multidisciplinary way. All of these activities have application across sectors, across disciplines, and we need to be exploiting those in order to stay ahead of the game. And then the final project, which is ongoing, is an innovation center, which we'll be building a new building for, starting in the next few months. But what I wanted to do now is to illustrate the capabilities of Westcott and the corridor and the opportunity we have by reference to the UK satellite launch program. Now, the UK, for various reasons, primarily being Martin Sweeting, has developed a reputation and a real capability in being a world leader in small, low-cost satellites. And this is a burgeoning area of economic development, basically driven by the same technology that gives you your smartphone. Stuff that used to take the size of this room can now be compressed down to a small unit that I can hold in my hand. And the same is true of satellites. With using current technologies, you can now design a tiny satellite that you can hold in your hand almost, which can do the job of what in previous generations would have been large multi-million-pound thing that would literally fill this room. And that is an area of great economic potential, which we can exploit. The only problem currently is that we're reliant on other people to launch these satellites. So if you try and make a business case to a customer saying, look, I can build you a very smart satellite and then do this, that, and the other, and he'll say, well, when can you launch it? And he'll say, well, I can't tell you because it depends on somebody else. You have to beg a ride on a larger vehicle, or it gets pushed off the side of the space station, the International Space Station, and basically you have no control when it's up there, and that's hopeless as far as developing a business case. So the UK government has recognized this over the last few years and is now developing legislation which ought to be passed through Parliament within the next few years to enable rockets to be launched from the UK. And they've also recently announced at Farnborough some startup grants, some grants to run a demonstrator launch out of the north of Scotland, and the consortium that's going to do that is led by Lockheed Martin, which is large, of course, as you know, probably the largest defense company, aerospace defense company in the world, which has a huge heritage in the launch business. They're working with the Highlands and Islands enterprise to launch and construct a spaceport on the north coast of Scotland, which actually turns out to be a perfect place to launch satellites into a sort of polar orbit that gives you complete coverage of the Earth. And the advantage of having these small satellites, which are very low cost, I mean, literally you can build one for a few £1,000s, you can build many of them. And that opens up the possibility of constellations of satellites. In other words, constellations, maybe 50 or 100 satellites, all working together to give you coverage around the Earth. And to give you an illustration of the sort of application that can enable, already Will Marshall and his group at Planet Labs have a constellation of satellites in orbit, tiny satellites which are taking images of the Earth every 15 minutes at every location. And that has clearly wide application. Another company that we're working on is Orbital Microsystems is developing an idea to measure the weather at every point on the Earth every 15 minutes. And I'm not talking about a weather forecast, but an actual weather measurement, which clearly is incredibly valuable for airlines and other operators which are interested in the local environment and understanding where hazards might occur. So the reason I raise that is that this is going to change the dynamics of the space industry completely. There'll still be a place for large satellites, one-off missions, but with constellations, 50 to 100 satellites, we're into low-cost production and low-volume production as opposed to one-off production. So it'll be much more like motorsport, for example, where you're building several tens of units, not thousands, but not one. And that's going to require a different approach, a different set of capabilities, which is something that we are starting to develop at Westcott, and which we can take advantage of the capabilities of the ARC to bring forward. So this is what you might see.
Keith, last minute.
This is the last slide. This is what you might see if you go to the north coast of Scotland in about 3 years' time. So this is an actual launch. The key thing is that if we play our cards right, the ARC or the corridor can be the engine of economic development, which takes advantage of this sort of capability. So with that message,
Thank you very much, Keith. Thanks a lot.